Welcome to pantechelearning. First of all, good evening to one and all. Welcome to pantechelearning. Welcome to pantechelearning. So today we are going to see about AI-based image classification on different object. Okay, so today we are going to see about AI-based image classification. So before we enter into this session, technical part, I like to give some introduction to deep learning with artificial neural network. And first of all, everybody will know about basically what is deep learning, right? So deep learning is nothing but it will be trained by the neurons. Okay, so we will have a neurons, and then we will have a hidden layers, and then we will have a output layers. So based on the input data, we are going to predict an output result. Okay, so this is generally simple artificial neural network algorithm. Okay, but here the main thing is we are going to use in today's session about CNN. Okay, so convolution neural network algorithm. So let me see what we are doing with this CNN. So first of all, what is convolution neural network means? Like it's a class of feed forward neural network algorithm. Okay, it's not like a recurrent neural network algorithm, it's a feed forward neural network algorithm and analyzing mainly for image. Okay, so analyzing mainly for image. Okay, so generally if you have any image type or video type of dataset, we are going to use these things. Okay, and so what is CNN? The computer vision is evolving rapidly day by day. It's one of the reason is deep learning. Okay, so why we comes into the machine learning to deep learning means because of machine learning is if you have a large amount of data, it won't give exact results. So that's why we are entering into the deep learning. And when we talk about computer vision, a term convolution neural network is important. Okay, so here computer vision is nothing but we need to open some cameras or web cameras. Okay, or you need to recognize your face by using your mobile cameras, means you need to use this computer vision package. Okay, so generally in Python the computer vision package will be available in OpenCV. Based on that only we are going to train. Okay, so if you are using OpenCV, the main thing you need to know, that is convolution neural network algorithm. Okay, so CNN is heavily used here. Example like CNN computers visions of face recognition or image classification, okay, etc. It is similar to the basics of neural network only, but CNN also have learnable parameter like neural network or weight, bias or loss function or activation function or something. Okay, so that is the use of CNN. And why should we use CNN? Okay, for example, if you take one image, generally if you take one image means it will be in the form of, first definitely we need to know about the image resolution. Okay, so here for example, here we are having a resolution like 224 into 224 resolution, and then here we are having a 3. What is this 3 means? That is the shape of your image. So here 224 into 224 resolution into 3 means like RGB. Okay, red, green and blue. Okay, so this image, if I want to do, that is if I want to train this image for my algorithm, deep learning algorithm, means first I will use the layer is called as a convolution layer. Okay, so first I am using here convolution layer. So here you can see without red box, it's called as a convolution layer. The box only have a black is called as a convolution layer. Okay, so I will apply both convolution and ReLU activation function. For example, suppose if I have an image like number 9. Okay, I have an image number 9. The main thing, the main important part of number 9 is like first one, this loopy pattern, and then vertical pattern, and then this pattern, right? So these are the important part of the 9. So when I combination of these all, we are getting a number 9, right? So combination of this part, we are analyzing, it's a number 9. Suppose if you are see dogs in roadside or anywhere, okay, how you are analyzing it's a dog? Based on the shape and based on the attributes, some attributes will be there, we are going to conclude that is a dog. Okay, like same thing only, whenever you are giving any image to the convolution layer, it will be try to predict some important features in your image. Okay, so that is the use of convolution layer. And here we are having convolution plus ReLU. Convolution plus ReLU is nothing but it's an activation function. Generally they will call as activation function. So try to get our output in non-linearity way. Okay, so try to get our output in non-linearity way. That's why we are using ReLU activation function. So each and every activation function have some formulas. Okay, generally the ReLU activation function range is like 1. So it will be give the output result based on that only. So this is the combination first layer, like convolution plus ReLU activation function. The next layer, that is here we are having a red color, right? Red box. Here we are having red box. So this is the layer generally used for like pooling. Okay, maximum pooling. Generally they will call as a maximum pooling layer. Why we are using maximum pooling layer? Okay, so see the pixel values of previous, that is resolution value of previous layer and then current layer. Okay, so it will be changes. Previously we are having 224 into 224 into 64, but now we are getting 112 into 112 into 128. Okay, so what is the thing is, we are going to reduce our data like this. That is, we are going to reduce our size of our input image. Okay, so why I am doing like this? So why I am doing like this, if I have this till the end, if I have this resolution 224 into 224, we need to create a more number of neurons. Okay, we need to create a n number of billion or trillion number of neurons we need to use as a input, as a hidden layer, and we need to predict. But if I use pooling method, I can reduce my data. Okay, 112 or 112 into 128 like this. Okay, so that's why we are using here pooling layer. Maximum pooling layer general example I will show you. Okay, so that's you assume that for the use of maximum pooling layer. Then after this I am going to use again fully connected layer plus ReLU. Okay, so here before that I am again using convolution layer with plus ReLU activation function. So we are getting 56 into 56, then 28 into 28 512, then 14 into 14 512, then 7 into 7. So like this I am applying both the convolution layer and pooling layer. I am trying to reduce my inputs. Okay, so then after I am reducing the inputs, I am going to convert my input into an dense layer. That is, sorry, I am going to convert my input, that is flattening my input like this. So why I am flattening means then only model can learn easily, then we can get an output. So I am flattening the output result like this, then I will be give it to the softmax function. Okay, so this is the whole architecture of convolution layer. And here image representation. For example, if we take a color image, we will have a totally 3 colors. One is red, green and blue. And then edge detection. So for example, white and gray into convolution, white and gray, black. Okay, so this is the filters. Okay. Okay, so we for example, if we take a 9, I already told you, if you take a 9 this is one important part, so I will take this as a one filter and this part as a one filter and then this part as a one filter. Okay, so like this I will apply some filter and then I will be get a output like this. Then I am going to use maximum pooling and all. Okay, so dataset description, today we are going to see about like a number digit dataset only. Okay, so we are having different type of images of numbers and then after that we are applying into the neural network algorithm, then we are going to predict an output result. So this is the digit. So layers in CNN, so we will be having input layer. Yes, we need to pass the input data, then convolution layer plus ReLU, then pooling layer, then after that fully connected layers, and then softmax and output layer. Okay, so here input layer is nothing but the image size and shape, and then convolution layer is nothing but we already seen each and every pixels of the data will be analyzed and then fit into the new filters. Then after that we are going to pass into the maximum pooling layer. Okay, so here you can see this is filters we are applying for each and every image, then we are getting an output I into k. So this I into k will be again passed into the activation function. Okay, for example, if I apply ReLU activation function, I will apply the ReLU activation function. After applying the ReLU activation function, I will be again pass the data into an maximum pooling layer. Okay, so I will show you. Here you can see this is the maximum pooling layer. So in pooling layer we are totally having two type, one is maximum pooling layer and average pooling layer. Maximum pooling layer is nothing but it will be take a maximum data. For example, here in 2 into 2 this matrix we are having 100, in this 2 into 2 matrix we are having 184, and then in this 2 into 2 having we are 12 and then 45. So we are getting an output pooling size as a like this. Average pooling is nothing but it will be take a average value. For example, here you can see the combination of this all the three we are getting average 36, and then combination of all the three we are getting average 12, and then combination of this all four layer we are getting an average value 18 and 15. Okay, so that is called average pooling layer. Okay, the next thing, just basic of fully connected layer and convolution layer, and then how we can apply fully connected layer. And softmax we are going to use here softmax only because we need to predict an output with a multiple class. Okay, so generally softmax or logistic layer is the last layer of CNN. It's resist the end of the fully connected layer. Okay, logistic is used for binary classification and softmax will be used for multi classification. Okay, and then output layer, then we need to know about Keras and TensorFlow. So why means the Keras and TensorFlow is the one of the most important package and for mainly for deep learning, and we are having even though PyTorch also, but PyTorch basically somewhat difficult one. If you are a beginner you can use Keras and TensorFlow for deep learning. So here first of all you need to know what is TensorFlow. Okay, so TensorFlow is nothing but it's a library package invented by Google. Okay, so the Google is the first invented by TensorFlow. Mainly the tensors are nothing but it's a multi-dimensional array object. Okay, so tensors are nothing, it's a multi-dimensional array object, and it generates the computational graph, and it's very fast. Okay, it's built by a C++ language, it's a very fast, and then the mainly it's used for like desktop application and mobile application. And even though you can create your model as a, I will tell you what is that model, how we can dump the model. Using the dumping model you can generate the Android applications also or desktop application also. Okay, so that is the use of TensorFlow. The next one is Keras. Okay, so Keras is nothing but it's a open source neural network algorithm library package for Python, that runs top of the TensorFlow or Theano. Okay, so Theano is nothing but another one TensorFlow package only. Sorry, another one library package of deep learning. Okay, so the both are run over the backend of the Keras. Okay, so whenever you are using Keras or whenever you are importing the Keras package, it will be automatically train. Okay, sorry, it will be give the import automatically as a backend these packages. Okay, then why we are using the Keras means we are going to build the deep learning algorithm means we are using this Keras package. So Keras allows the user to models on smartphones like iOS, those things and all. Okay, so the next thing, that's it about presentation. This one, I think this is enough. Okay, so let I enter into the technical part and I will show you how we can apply the Keras and TensorFlow for number digit recognition. Okay, so I already told you we are using here number digit dataset. So here you can see, first of all we are importing some basic packages. Like here I am using Jupyter Notebook. Okay, so if you need to install the Jupyter Notebook, you need to install the application name the called as Anaconda Navigator. So using Anaconda Navigator only you can implement it. Okay, so here you can see Keras package, that is we are importing the package available online using the MNIST datasets. Okay, then model, here I am importing the sequential model. Then layers, okay, we are going to use dense, dropout, unflattened layers. Then I am using the convolution 2D and maximum pooling 2D. Okay, so these are the packages I am going to use for my program. Then next one, I am going to load the dataset. After loading the dataset, I am going to save my dataset in train data and test data. Okay, X train and Y train and X test and Y test. Okay, so what is the thing here we are doing means, like we are downloading the dataset from online. Okay, the dataset will be a number digit dataset like 0, 1, 2, 3, 4 like this. Then we are dividing this dataset into two types. One is like train data and another one is test data. Okay, train and test. So here we are having train data and test data, but in this train data and test data we are having totally two variables. One is X train, another one is Y train. So X train is nothing but pictures of the number digits. Okay, X train is nothing but picture of the number digit, and Y train is nothing but output of the number digit. For example, here 0, 0, 0 like this, so it's called this, all the row, first row will be called as a 0, 2 like this. Okay, so here that like all the pictures will be available in X train. Okay, and output will be available in Y train, like same thing only X test and Y test. Okay, so that's why I am taking. And if I check the shape also, we are having a totally 16,000 image 28 into 28 megapixel, and then 16,000 image in output in Y train. Okay, so 16,000 image and 28 into 28. So see here I am not getting a layers. Okay, why? Because all the image in the form of black and white. Okay, so I am not getting any 16,000 28 28 3. If I get 16,000 28 28 3, if I get 3 means it's a color image. Here I am not getting, only we are getting 16,000 28 28. Okay, now here in Y train we are having an output of that 16,000 image. Okay, so now I am reshaping my train data. Okay, how I am reshaping means like x train dot reshape. How I need to reshape the data means like this 28 comma 28 1. Okay, 0 comma 28 comma 28 1. Okay, so previously I am getting like this. Suppose if I print the data, I am running executing this line, then now if I here I am getting output result x train dot shape like this. Then after I am running this, I am getting what I am getting here, x train dot shape. Okay, here I am getting extra one layer. Okay, how it's coming? By basically by applying this x train dot shape. Okay, so x train dot shape, first one always it's a row, and then next if I use like this means it's a column. Okay, so in row, that is in 0th row, I am adding another one layer 1, and in test data also I am adding another one layer 1. Okay, so totally I am getting a now shape like this 16,028 comma 28 comma 1. Previously I am getting like this output. Okay, so input shape should be in the form of like this. Okay, so that is the use of this one. Why I am doing like this means I need to pass the input shape during I am creating a convolution architecture. Okay, so that's why we are using this one, this two line. Okay, so now I am going to convert the class vector to the binary class vector. How I can convert the class vector into the binary class vector means by two categorical function. This function we already imported, I think x train. Okay, so from Keras itself directly imported, but if you need also you can import like this from Keras dot utils utils. Okay, then import to categorical. Sorry, here I imported util list, right? Utils, then import to categorical. So like this also you can import, but here I directly called my Keras utils dot to categorical. Okay, so like this also you can try here y train and y test. Y train is nothing but my train data, y test is nothing but my test data outputs. This both the outputs will be converted into class vector to binary class matrix. Okay, so here you can see if I print the y train, I am having an output like this. Okay, I am getting an output like this. So for example, if I print the y train one first in data, I am having a 0, that is y train first image, that is in train data first image, first image is 0 only according to the Python index value. Y train, in train data the first image is 5. Okay, so that's why I am getting here output 5. Okay, so this output I am converting into the binary class matrix. Okay, so this output will be converted into the binary class matrix. What is binary class matrix means? If this is now I am having this vector value, I can convert this binary class matrix. How means? By applying this two categorical function. Okay, how it's working means, for example here I am getting an output 5, right? So if I apply two categorical, I will convert this output into like 0 0 0 0 1 0 0 0 0. Okay, so like this I will convert. Okay, so let me check the output now. Okay, same y train 0th data will be checked here after you running this code. Okay, now I am creating the new shell, then I am printing the y train out. See here, So that is the use of two categorical value. Okay, so you can convert your vector into an binary class matrix. So that is the use of this one. After converting, I am converting my train data into an float 32. Okay, so currently I am having my train data. What is the type? Let me check. I'm having the type npy and nt array. Okay, so previously we are having an type of this 0. Here we are having an data like this. Okay, so these are pixel values of each data. So if I print the values, I am having the type uint8. Okay, so I am having the type uint8. Now I can convert my type into a float. Okay, so then I am save it in xtrain. Like same thing we are applying for this one and xtest. So now if I print this xtrain again, okay, previously you seen the output, it's a long output in array value. If I print again 0th image of the data, so where is the data I'm having? It's in the form of like here you can see, just wait a minute. Still it's uint type. Okay, so I till now I am not run this cell. Okay, now it's converter. Again if I run this cell, I will be get an, I think so. See here, float 32. Okay, previously uint32 is there. Now I am getting float 32. Okay, so if you see any values in your data, it will be in the form of like this float value. Okay, so that is the use of this float conversion. Then after I done this one, I am going to again normalizing my data value by this one. Okay, if I run this steps and again if I print the xtrain, what will be the output? Let's see. Xtrain 0. Now here you can see totally it's changed, right? So if I check the, here you can see previously I am having a float value, right? But now I am getting that float value into an decimal value. Okay, so that is the use of this one. So if you check data type, same float value only, but I divided my float value into an 255, then I am getting an output like this. Okay, so that is the use of this one. The next one I am using here shape. I am checking the shape of my train data and test data. So just I am for my understanding. So the shape is this one, totally 16,000 train sample and 10,000 test sample. Okay, so here I am applying a variable batch size 128. Each and every iteration it will be do 128 image classes, and number of classes is 10. That is 10 output classes, right? 0, 1, 0 to 9, 10 output classes, and then approaches equal to 10. That is number of iteration. Then I am importing the sequential model. After importing the sequential model, here I am applying my convolution layer. First one is I am applying the convolution layer like 32, then kernel size is equal to 3, activation, relieve activation function, input shape. What is the shape? We already defined the input shape. This is my input shape, 28 into 28 and one layer. Okay, so this is the input shape. Now I done with this. The next thing I am going to use convolution 2D again, then 64, 3, activation, relieve activation function. Okay, then after that maximum pooling layer, here I am applying 2, 2 matrix, it will be check the maximum. Then I am applying the dropout function. Dropout function is basically used to reduce the overfitting. Okay, so when I am having a neutralized any unimportant neurons, I can drop the layers, drop the neurons. Okay, drop the neurons. So that's why we are using dropout. So here 0.25 means like in 100%, 25% of neurons will be dropped out, then balance 75% neurons will be moved on to the flattened layer. So flattened layer, in name itself we are having a suggestion, we are flattening the output result. Okay, after flattening the output result, we are creating a 256, okay, 256 neurons, and then in the 256 neurons I am going to drop out my 50% of 256 neurons. Okay, then I am going to use num classes. Here number of classes, how much? We already know the number of classes, right? Totally we are having classes like 10, right? 10 number of classes. So I am using number of classes here. Here I am applying a softmax function. It's a multiple type of classification. Then next one I am using from Keras, losses, categorical, cross entropy, and then optimizer is equal to Keras optimizer delta, and then accuracy score. Okay, so this is the model compilation, and I am going to train my model by passing the train data. Batch size we already given here, batch size 128, and then epoch we already given 10 epoch, and then verbose is equal to 1, and validation data here I am giving test. So during training time itself automatically model will be learned. So for first iteration 1,10, for first iteration for 16,000 image I am getting an output result like this. Accuracy score will be an 0.92. Yeah, it's a nice accuracy score. My last value will be a 0.24. Then next iteration it's reducing my output last value but increasing my accuracy score. Okay, so at still last iteration I am having 0.0203, but accuracy 99% accuracy result. Okay, so now 10 times, that is 10 times this iterator model will be learned properly. Then I am going to save my model by applying this model.save minist h5 file. Okay, so if I run this file, my model will be saved here. Okay, you can use this model to convert your model into an whatever you need, TF Lite or any. If you need to use Android application, you need to convert this model into a TF Lite model, then you need to use it as a background. Okay, here I am saving the model. After saving the model, I am going to evaluate my result by giving my test data. Okay, so after giving my test data, after that I am going to evaluate that test losses equal to this one, test accuracy score. That is first, if I give the test data to evaluate that function, I will be get totally two score values. The first score value is nothing but it's a loss value. The next score value is nothing but it's a accuracy value. Okay, here loss is 0.024 and accuracy is 0.99. Okay, so this is the way you can predict your multiple type of images by applying your convolution neural network algorithm. Okay, so anybody have any doubt regarding this? If you have any doubt, you may ask using your comment section box. And this program have free certificate, online certificates are available. Okay, so if you are want a certificate, you can register with your link, that is attendance links are available in our description. You can use that link and then check it out. Okay, so you will be receive the certificate to your mail ID if you are registered for if you are use that link means. Okay, so fill the form and then check it out. So what are the doubts you have, you just ask it in our comment section. I will explain you. So like this we are having, even though I am having how to apply the color image. Okay, how to apply the color image also available. So here you can see importing the same sequential, dense, flatten layer and maximum pooling layer, then two categorical, and then here I am downloading the CIFAR10 dataset. This dataset is basically used to here you can see this is the dataset which we have: aeroplane, automobile, birds, cat, deer, dog. So this is the color image, right? Previously we trained on just black and white image, but here we are training a black color image. So if it is a color image means generally will be have a layers. Okay, 3 layers RGB. So based on that we are going to train the algorithm. Then CFAR10.load data. So I am loading the data of train data and test data. Then after training that I am going to use X-train and checking the shape. Here I am getting 3 layers. So previously we are not getting this layer, we only added the layer, but now I am using 3 layers. Okay, then after that if I check the train data I am getting layers like this, and then if I plot the images I am getting like this. Okay, if you need means you can plot the image also for our number digit right. X-train, here I can give X-train underscore, and we need to import the package name, import matplotlib dot pyplot as PLT. Okay, so again you can run it. Then where is my input? I am show X-train unexpected EOF, type error. So what is the type error? Invalid shape. Okay, invalid shape of image data. So what I am need to do means deleting the image, deleting the whole column. Then after reading the image I am going to check the output. Okay, to check the output, see I am getting a result, it's a 3, image name it's a 3. Okay, so this is the output of my image. So if I give here 100, my image is, it seems like a 5 or something. If I give 1000, 0. Okay, so 0th image. So like this you can plot your image by using matplotlib. Okay, so like that only I am done in previous this dataset. Okay, so like same thing what I done in our number digit, like same thing we are doing here, and then we are applying a maximum pooling layers and then same CNN, same training and testing. Okay, so anybody have any doubt? Yes. Good evening to all. What's the difference between YOLO and CNN? So YOLO and CNN, what is the main difference means? Like YOLO is like they are collecting a n number of images and they are training the algorithm, training the model, deep learning model. Then they are converting our model into an different type of version. Okay, so if you are searching for YOLO version 3, it's a real-time object detection. Okay, extremely fast and accurate. Mostly this is the current version of YOLO. Okay, so what is the use of CNN means? You can train your own model. Okay, you can train your own model, then get an output result. Here you can see for my model, for my CNN model, I am, after training the CNN model, I am dumping the code minis.h5. So we are getting here my model. So like this only. Okay, the extension of YOLO. What is the extension of YOLO? Let's check. YOLO version 3, version 2. So here, just wait a minute. So this is the YOLO, right? Car, bus, okay, and then traffic lights, persons. This is the use of image, okay, and here they are doing like this process, and then we are getting, okay, how to calculate the time taken to train the model. So here we are having already time taken. How here you can see for first iteration I am having 67. The time is taken as 67 seconds. Next iteration 84 seconds, 94, 85. There also time is mentioned. Okay. So just to check it out. Any other doubt? Okay, so that's it for today's session. If you need any other certificate for this webinar, you can check it out, the description link. Okay, the certificate link is available. You can check it out and register for that. Your certificate will be received into your mail ID. Okay, so up to this, anybody any doubt? You may ask. And we are offering for, even though online internship, and then technology we are working like Python programming, machine learning and NLP, deep learning and AI, blockchain, data science and big data, AR and app development, network simulations, those things and all. So if you are interested means you can join with us as an internship or training. And thank you. If you have any other doubt, you may contact us on itsori.java@pantechmail.com. And if you have any other queries, you may contact these three numbers, Mr. Sendil Kumar and Mr. Srinivasan and Kumarasamy. Okay, so thank you all. Thank you for this attending wonderful webinar. Have a nice day. How to link this technique with CCTVs? Yeah, we can link the technique by using OpenCV. Okay, so using OpenCV, for example, you need to collect the images. For example, you can take your image, 100 image or 200 image, then you can train the convolution neural network model. Then after training the convolution neural network model, converted into the H5 file. Okay, after converting into the H5 file, you can uh, run your camera. Okay, so normally if you need to open your web camera, we need to use the OpenCV library package. Using OpenCV library package, you can run your web camera. Then this, after opening your web camera, the camera will be capture your image, current live image. That live image will be transferred to the data, that is particular variable. We can convert that variable data into a frame by frame. Then we will give the input to the convolution neural network algorithm. Means automatically it will be give the output result whether it's you or some other. Like this also we can connect with not only CCTV camera, if possible we can made with our own laptop cameras also. Okay, so thank you for this. Thank you all. Have a nice day.